Hello students, today we are going to learn about speed and velocity, right? So speed and velocity. Now mostly you will see speed and velocity being used interchangeably, but there is a difference. There's a lot of difference. So speed is a magnitude of something moving, right? So when you talk about speed, you will not talk about the direction, right? But when you talk about the velocity, you will talk about the magnitude and direction. What is magnitude? So this leads to a new concept of magnitude. So magnitude is the size or extent of a physical entity, anything, right? So that is magnitude. Now, when you talk about speed, you talk about magnitude only, right? But when you talk about velocity, you will talk about magnitude plus direction, right? So anything that is only about magnitude is a scalar quantity. Now this brings two different concepts. So one that has only magnitude is called scalar quantity, and the one that has magnitude and direction is called a vector quantity, right? So now to learn speed and velocity, we need to understand two different concepts. One, what is the scalar and vector quantity, right? And the second, what is magnitude, right? So when you talk about a scalar quantity, it is magnitude without any direction, right? So that is how speed is, what speed is. There are other quantities like mass, time, temperature, those are all scalar quantities. We will discuss scalar quantities and vector quantities in detail in future lectures, but for now you understand that speed is a scalar quantity. Now what is a vector quantity? Something that has magnitude and direction both. That means there is an item, there is a thing that is moving, but in which direction it is moving, that is also important. So that is called a vector quantity. Now magnitude, as I explained, it is the size of something. Now when you talk about speed, how do you calculate it? So you understand the difference between speed and velocity in a moment. So just for understanding, I will write here, speed is a scalar quantity and velocity is a vector quantity. So now let's talk about the formula. Speed, the formula of speed is S, that is speed, is equal to distance upon time. So d is distance and t is time. So how much distance is traveled in how much time, right? That is the formula of speed. Now the formula of velocity is often represented as v and an arrow at the top that defines that vector. Velocity is a vector quantity and it is displacement upon time. So this delta sign denotes that this is a displacement. Alright. Now we are hearing different terms, distance or displacement. So distance again is a scalar quantity, but displacement is a vector quantity. Now I will explain distance and displacement in future lecture. So for now, understand the distance is you have an item moving in any direction and reaches a point. The length that the item has covered, the thing has covered, is the distance. Now you have an initial position and one thing has moved on the east direction and then it has moved in the north direction. So this position, the final position of that object from the initial position is the displacement, and that is what you use to calculate velocity. To calculate distance, you will take the complete distance that the object has traveled. So now, let's say there is a bike rider who is riding from this position to this position and from this position to this position. So this is 100 meter and the time taken to travel this 100 meter is 1 second, and then from here to here it is again 100 meter. And the time taken to travel this is 1 second, right? So the speed of the object is distance traveled, which is 200 meter, and time taken is 2 seconds. So the speed is 100 meter per second. So this is what the speed of the object is. Now let's take the example of velocity. So velocity is the displacement upon time. So time taken is 2 seconds still, but the displacement is, this is the initial position of the object. It has traveled in the east direction. This is east, this is north, let's say, right? So the distance traveled in this direction is 100 meter. Then in the north direction is 100 meters. So the displacement is, let's say, this is 150 meter, right? It's not 200, so it's like 150 meter from the initial position. So 150 meter in 2 seconds, which will be 75 meter per second. So there is a difference when you talk about speed and velocity, right? So in speed, you need to take the distance into account. When you talk about the velocity, you need to take displacement into account. Again, distance and displacement are one is a scalar, distance is a scalar, and displacement is a vector quantity. I will explain the scalar and vector quantities more in future lectures, but this is for speed and velocity. Now let's take one final example that will etch in your mind permanently to differentiate between a speed and velocity, right? So let's take an example of a circle, okay? So you have a circle, right? And you have an object moving from this position and taking moving around the circumference of the circle, right? So when you calculate the speed, right? So speed will be the distance traveled upon time. Let's say the circumference of the circle comes out to be 100 meter, right? And the time taken to complete this is 10 seconds. So the speed of the object to cover this complete distance will be 10 meter per second, right? But when you talk about the velocity, right? So when you talk about the velocity, the displacement of the object, when it starts from this position and come back to the same position, will be 0, right? And no matter what time it takes, so let's say it takes the same 10 seconds, right? So the velocity of the object will be 0 meter per second, because the object has not displaced from its initial position. It has the final position and the initial position is same. That's all for today's class. We'll discuss more in future lectures. Thank you.